Hi kids, today we're going to start something new. We're going to talk about metals. Okay, now, do you remember what we call the arrangement in a metallic bond? So in a metallic bond, you have to remember that metals are solid. So they are arranged in a lattice arrangement, right? Now, not only are they lattice, they are actually not atoms, but they are metal ions. For example, if this was a piece of iron, every single one will be a Fe2 plus ion. Okay, so are they arranged in a lattice arrangement? Yes, but they release their electrons and their electrons are freely moving. So this is a sea of electrons. So this is why metals can conduct electricity in a solid state, because of the free moving electrons. So remember, what is the arrangement in a metallic bond? Lattice arrangement of positive metal ions in a sea of free moving electrons. Now, every single metal in the world has the same arrangement. I mean, it's not Fe2 plus, but every single arrangement is the same because all metals can conduct electricity. Now, these includes all metals in group 1. For example, potassium, sodium. Metals in group 2, for example, calcium and magnesium. Metals in group 3, for example, aluminium. This also includes all transition metals. So transition metals or transition elements all are also metals. So this include metals like copper, manganese, nickel, gold, silver, alright, iron, and so on. So regardless whether they are transition metals or group 1, group 2, group 3 metals, they are all metals. And all metals have the same general physical properties. These are, they can all conduct electricity, they can all conduct heat, they are all shiny for after they are polished or freshly cut. They are all able to be malleable and ductile. Okay, so this is the general properties of all metals. Okay, all metals. So these are known as physical properties. Now, what happens is, what are the chemical properties of metals? So, metals can generally all react with oxygen and also can react with acid. Okay, now of course some metals will react more violently, some less, but generally they can all react with acid and all can react with oxygen. Okay, now let's focus on the differences between transition metals and non-transition metals. Okay, so regardless whether you are a transition metal, meaning iron, copper, nickel, or you are a non-transition metal, let's just use a general group 1 metal, potassium, sodium, or lithium. Alright, now they all have the same general properties, meaning that they can all conduct electricity, can all conduct heat, are all shiny, are all malleable, and they're all ductile. Okay, now when they ask you to compare specifically between transition metals and group 1 metals, then it's slightly different. So group 1 metals have lower density. So therefore, transition metals have higher density. Okay, please remember, this is one difference. It's not two differences. It's transition metals have higher density, group 1 metals have lower density, but that's only one difference. So I'm just going to talk about one. So generally, transition metals are harder. Okay, transition metals also can be used as a catalyst. For example, iron can be used as a catalyst for Haber process. Nickel can be used as a catalyst for hydrogenation. And not only transition metals can be used by a catalyst, transition metal compounds. For example, manganese 4 oxide is used as a catalyst for hydrogen peroxide. So it can be used as a catalyst. However, group 1 cannot be used as a catalyst, and group 1 is also softer. Okay, now transition metals form colored compounds. Please remember, they are not colorful. They form colorful compounds. However, group 1 metals only form white compounds. Okay, so this example is, for example, iron 2 chloride is green, potassium manganate 7 is purple, copper 2 sulfate is blue. However, group 1, potassium sulfate is white, sodium chloride is white, lithium carbonate is white. You get the picture. So that's the difference between transition metal and group 1 metals. But if they ask you what's the similarities, remember, they can all conduct electricity, they can all conduct heat, they're all shiny when freshly cut or polished, they're all malleable, and they're all ductile. Okay, now let's go back to this. Metals. Why are metals ductile and malleable? This is because the atoms or the ions are arranged in layers. And when you push or pull or knock it, the layers of atoms or ions, when you're answering this, it doesn't really matter, the layers can slide over each other. So because they can slide over each other, they are malleable and they are ductile. So how can we overcome this problem? So this is where we use something called an alloy. An alloy is a mixture of metals or a metal with a non-metal. For example, steel is 99% iron and about 1% carbon. So let's say this is a carbon atom and this is an iron atom. When you have a mixture of iron and carbon, what happens is they are no longer arranged perfectly. Instead, it disrupts the layers. So now what happens is they can no longer slide over each other. So because they can no longer slide over each other, the atoms can no longer slide, they are harder and they are less ductile. So this is why alloys are stronger, harder as compared to a pure metal. So that's the difference between an alloy and a pure metal. Okay, so examples are of course steel. Okay, steel is an alloy. Another example of an alloy is brass and bronze. Okay, now both of them are alloys of copper. Now let me give you a trick of how to memorize. Now tin is Sn, right? So bronze already has a Z here. So copper and tin make bronze. Okay. Zinc is Zn. So brass already has a S here. So copper and zinc make brass. So these are examples of alloys. Alright, so I hope this helps you. See you soon.